Okay, now they move you into the secant and the cosecant functions. And you have to remember that secant is the reciprocal of cosine, and cosecant is the reciprocal of sine. And here's the two graphs. I took screenshots from your textbook. And they're showing you, let's see, they're showing you in the blue graph the cosine, which is the blue curve, and then they're showing you, hello, green, with the green lines, the secant, and they're reciprocals of each other, because that's what they're reminding you down here, is that secant is 1 over the cosecant. So every point is the reciprocal. And it's really kind of funky, but the green graph, I'm going to continue it. It's got like these curves here, and then a curve here, and then a curve here, and then up down here is a curve. And they fall in between asymptotes. Because when you're in the denominator, you can't have 0 down there. So any value of x that's going, when you take the cosine of it, is going to give you 0 will be left out. And that's what all those dashed lines are. And then the sine and cosecant kind of looks almost identical. They're just those U's in between, you know. It's the same kind of basic shape. It's just because of where the sine and the cosine start, that's what makes the difference. And for the cosine, normally I start right here and it goes down and comes back up and ends at 2 pi, whereas the sine starts at the origin, goes up, goes down, comes back up, and also ends at 2 pi. If you're, and then Mobius gives you this little box of information here again, but your period is, we're back to the 2 pi again, so it's 2 pi over b, because cosine and sine's basic period is 2 pi, so the reciprocals are also 2 pi. It's the tangent that's kind of weird. And then, so when you get to this problem, participation activity number 3, it says select the correct graph of one period of f of x equals -2 secant of 0.4x. So I went ahead and calculated the period. It'll be 2 pi over the absolute value of 0.4. And the absolute value of 0.4 is 0.4. And 2 divided by 0.4 gives me 5 pi. Now, I know that the secant is the reciprocal of the cosine, and the cosine function, okay, you have a, let's see, an amplitude of 2 right here. It's actually a -2. But for a +2, if you were doing cosine, it would, and I'm just going to grab the first graph here, it would start right here, and then it would go down through pi, down, well, that's 2 pi. Sorry, they don't have it quartered off. Well, anyway, I'll just show you. It would go down and then up, cross, down, up to there. That's what one period of your cosine would normally look like. I'm not doing it in the right pi. It's the wrong graph. But instead of starting here, because it's negative, it's going to start down here. So I'm looking for a graph that actually has the hump down here going through -2. So it's obviously not that one. And then I took screenshots. This was the first graph, this was the second, this was the third, this was the fourth, and this was the fifth. So because this one starts like that. That one's out. Same thing here. That one's out. Now these three, they all go upside down. So they're going through the -2. Going through the -2. Ah, this one's out. This one's out also because it's not going through the -2. They've shifted that to the right. The only time that it would shift to the right is if you had, you know, some more in here. Like, what's the function say up here? That would be the bx minus c. You'd have to have a minus c in there to get it to shift to the right, and we don't have that in this function, so it can't be 5. 5 is out also. Okay, so I've narrowed it down to 3 and 4. Now this is where my period comes into play. The 5 pi, it has the cosine function or this function, whatever, reciprocal, has to have a span of 5 pi throughout the whole thing. And so I just kind of have to look. It's going to be one of these two, 3 or 4, but this one starts at this dotted line at -5 and ends at this one, sorry, -pi at 3 pi. That is 1, 2, 3, 4. That's only 4 pi. This one's starting at, I don't know, to the left of -pi. Well, this is 1, 2, 3, 4. And then if you take this and this little piece over here, these two sections together, that makes 5 pi. It's number 3. And I already double checked it and got my green. So it's the third one down. 1, 2, 3. It's been a while since I've had to explain this stuff, so forgive me if I don't sound too, I don't know. I haven't had a lot of practice at it. I know what I'm seeing, just how's it coming out of my mouth? I don't know. So, and with all the color, I hope you understand what I'm saying, because 5 pi, the period has to go from here to this dash line to that dash line, because you're going to get this hump and this hump. You get 2 humps to make an entire period, because normally when you're doing the cosine function, you get, I'm trying to show it here, the cosine would be, you know, down. I'm not doing this very good. It goes deet, 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 deet. There's like a, you've got like half the hump on this side and the other half on this side. Oh well. Anyway, I counted 5 humps. I just had to put a partial hump at the right end and the other partial hump at the left end to make my 5, you know, units of pi in between those 2 vertical bars.